In this question, we're given a river, and we're given two straight sides either side of the river. T is the base of a vertical tree here. Connor's property is at C. And we have a couple of triangles. So we have a visual from D to the top of the tree. It's 30 degrees. E is the top of the tree. And from C to the top of the tree is 60 degrees, the red line. So use the triangle ECT to express TE in the form root A CT meters. So just draw the triangle ECT. We have a 60 degree angle in it. And this has to be 90 because it's drawn directly to the base of the tree. We have E at the top, we have a T, and we have a C, and we're dealing with TE and CT. So it's it's tan. We're opposite and adjacent. So the tan of 60 is equal to O over A ET over CT. Tan of 60 is root 3. So root 3 times CT is equal to ET. In the next part, you're asked to show that TE may also be expressed as 225 plus CT squared over 3, or the square root of all that. So let's jump back up. We have a 15 here. We have DT here. And we have CT along the bottom. So if we use that right angle triangle, 15 is here. This is D. DT is opposite the right angle, and we have CT down the bottom. So DT, we're looking for a CT squared. So DT is equal to, the diagonal is equal to the square of the other two sides squared and added together. So DT is equal to the square root of 225 plus CT to be squared. Now we need to go back up into the other triangle, this one here. We have a 30 degree angle in there. Let's come off to the right here just so we can see it. We have a 30. We have ET. We're looking for DT. So we can say that the tan of 30 is equal to ET, phone home, over DT. Tan of 30 is 1 over root 3. That's equal to ET over DT. And we must have some information. We have ET here in terms of CT. So we're looking for ET or TE. So let's write TE or ET. I'll keep it as ET. I think it's better. It sounds better. That's equal to DT over root 3. And we have DT here. So ET or TE is equal to the square root of 225 plus CT squared over root 3, which is the same as taking the root 3 inside the square root. So we can create a double fraction inside 225 plus CT squared over 3. That's the same. I'll revert back to TE at this point. Part C of this question, you're asked to hence find CT correct to one decimal place. So we have two values for CT. We have this one here. We have, two values for ET or TE, which both have CT in them. So we can say that root 3 CT is equal to our other value for TE, this guy here, the square root of 225. Square root of 225 plus CT squared over 3. So we need to isolate CT. So if we multiply, or we square both sides, we'll get rid of the square root. So why don't we do that? So we get 3 CT squared on the right hand side. Sorry, the left hand side. The right hand side will become 225 plus CT squared over 3. If we multiply both sides by 3, we're going to get 9 CT squared is equal to 225 plus CT squared. So 8 CT squared equals 225. So dividing by 8 and getting the square root, we'll get CT. So 225 divided by 8 and the square root of that. And we're asked for 1 decimal place. So on a calculator, this is giving me 5.303, well 30, well that's just 1 dp, then we 5.3 meters for CT. In part D, we're asked to find TE, the height of the tree. So we have a value in terms of CT up here. We have again this one. Root 3 CT is equal to ET. So root 3 by 5.3 is equal to the height of the tree. And typing this into a calculator, and it's correct to 1 decimal place, we're going to get 9.17. So 9.2 meters for the height of the tree. Part E, we're told the tree falls across the river and hits the bank at Connorside at point F. Find the max size of the angle FTC, answers in degrees to 1 decimal place. Okay, let's just check our diagram here. The tree falls across, now we're assuming that the top of the tree hits the bank here. So we have a right angle triangle. We've already worked out C to T, and TF is the same as the height of the tree, which is TE. So we're FTC, so we're looking for this angle in here. So we have this side, and we have this side, so that's A and H. So CT over TF, the cos of the angle is going to be equal to, so the cos of the angle, we'll call it A, the cos of the angle is equal to CT over the height of the tree, which we actually have in terms of CT as well. We have root 3 times CT. Now we could use the 5.3 and the 9.2, but we've rounded them off, so just to be exact here, we're going to say it's going to be root 3 CT on the bottom. So that's going to give me 1 over root 3. So the inverse cos of 1 over root 3 is equal to 54.735, so 7 degrees. If we use the 5.3 and the 9.2, let's see what we get. The inverse cos of 5.3 over 9.2 is equal to, that's going to give 54.82. And is there a difference between these? Yeah, we got 54.7. So rounding off too early in this question, which you were asked to do, then will cost you a mark in the final part. So just be careful to use the exact values if you have them. In the final part, part F, if the tree was equally likely to fall in any direction, find the probability that it would hit the bank at Connorside when it falls. Answer as a percentage to 1 decimal place. So let's have a look at this diagram again. So that's the max. If it goes any further this way, it's not going to hit the bank. So if it hit the bank over this side as well. So obviously these angles now, this angle would have to be twice the angle that we got previously. And actually we have a circle around it here, so the probability of it hitting the bank is going to be that angle as a fraction of 360. And then times 100 for percentages. So what did we get? 53.7? 54.7. So twice 54.7 is 108 and 1.4. 109.4 over 360 times 100 is going to give me 30.38 repeating. So 30.4% chance of hitting the bank on Connorside. That's the end of this question and the 2017 paper 2.